Okay, so on this question, we're looking for the area of the circle with radius r. Let A be the area of a circle with radius r. If dr dt is 4, find dA dt when r is 2. Okay, so that's not a very good circle. Let's draw a circle. Well, I still thought this would kind of automatically do better. There we go. All right. So we have a circle and it has a radius. Our R is from the radius from the middle to the edge. And the area, what's the area of a circle formula? Well, it's pi r squared. So now they're asking me about dA dt. So it makes sense. I'm going to go d dt of the left side and d dt of the right side. So I'm going to take the derivative, implicitly of both sides. Um, both sides. So it's implicit. Why is it implicit? Because T is different than A or R, right? If it's a different letter, that's implicitly. How do I know it's T? Well, they all have DT in the bottom. Because, yeah, all right. So what do we have on the left side? We have dA dt equals, now what about the right? Pi, remember, is just a constant. So you got to take the derivative of this side, what's going to happen? The 2 is going to drop down, 2r, subtract 1 from the power, but times dr dt, or r prime, whatever you want. Does that make sense? So I did the derivative of r squared, which is just going to be 2r, but then because r is not t, times dr dt, right? That d dt. So I'm taking the derivative of this side with respect to time and the derivative of the other side with respect to time. If the area of the circle is equal to pi r squared, then how fast the area of the circle changes over time is going to be equal to how fast this formula changes over time. So dA dt, the rate of change of the area over time, is pi 2r times the dr dt, the rate of change of the radius over time. See, what's happening is the radius, as it tells us right here, the dr dt is 4, meaning the radius is getting longer by 4 every unit of time. I don't know if this is 4 every minute or whatever, but the radius, whatever it is, well, they tell me actually the radius starts off at 5. And then 1 minute later, it's 4 more. It's a total of 9. And a minute after that, it's 4 more, etc. Every minute it goes up by 4. I don't know if it's a minute, but every unit of time. But they didn't tell us what unit of time they're using. That's fine. It's getting bigger and bigger and bigger, which means if the radius gets bigger by 4, it's originally 5, as they say, then the circle's area is getting bigger. All right, so that's the question. Find dA/dt. Find out how fast is the circle's area getting bigger. So dA/dt when r is 5. So put in 5 and dr dt is 4. Put in 4. So it's pi times 2 times 5. It's kind of scribbly. Times 4. And so that's going to equal, what is that? 40 pi? 40 pi. And I'm sure you could put the answer in that way, or you can put it in that way. Either way, that's how fast the area changes. So the area is getting bigger by 40 pi, or 125, almost 126 units every minute when the radius gets bigger by 4 units every minute. So if every minute the radius gets bigger by 4, the area gets bigger by 125.6. That's what we just figured out. So there we go.